Okay, what are we looking at here? We are trying to prove that this triangle. Let me highlight them in two different colors. Um, we are trying to prove that triangle PQT, PQT, PQT is congruent to triangle PVR, PVR. Okay. And we're given some information, the information specifically that we're given, and it's already marked for the angles. They say angle T is congruent to angle R. That's convenient for us to know. We also know that PQ, and I will indicate this here, PQ is congruent to PV. That's handy because that is the small side of each one of the triangles. So we've got an angle that's in common. We've got a side that's in common. If we could only prove something else, well, we really don't have, we've got an opposite angle inside, so we can't really do like side or angle side angle because we need to have those be, one of them be included, but they're too far apart from each other for that to happen. But there is one thing that you can have, which is that you have two angles and then a side. So we don't have to worry about that. Well, let me just for a second, let me redraw, let's say, PRV like this. What I'm talking about is that you've got this angle here, and then you've got that side congruent on both the triangles. But between that side and that angle, you've got another angle and another side, another angle and another side. So they're never gonna be, you're never gonna have something next to it, like another side, that would prove like side angle side because it's not included. Okay, and you couldn't get another angle because wouldn't have angle side angle. But the one rule that we have where we don't have to have the odd thing out, the other either two angles on a side or two sides in an angle, the thing that you only have one of has to be included is when you're dealing with angle side. Angle side allows you to have two angles and a non-included side. Hopefully you know the reason for that is that if you know two angles, you know the third one. So it's really kind of a variation on side, or angle side angle rather, sorry. But this is what we've got. If we could only prove one of the other angles, that's how I know that it needs to be an angle, because I know that we can have two angles and then a side. So luckily they actually share an angle, and that angle is that top angle right there. Okay, so we now have angle side congruence between those two triangles. So let's look at our rules here. I'm going to fill in A, B, and C right below in our flow proof, and then I'll fill in D below and E below right where you see them. So let me type them in. So the first thing that we've got is angle T is congruent to angle R. And how do we know that? That was given to us. Given. Super. How do we know that angle TPQ is congruent to angle RPV? That's the green one. And that is, we know that that's true because that's the same angle really. So we're using the reflexive property of congruence. Great. And how do we know C that PQ is congruent to PV? That was a piece of information that was given to us. You see that up on top right there, given to us. So I'm just going to type given. Great. Now, because of those three things together, we have angle side congruence. We know that triangle TPQ is congruent to triangle RPV. How do we know that? We know that by angle side. Now, we can then say, okay, once we know that that's the case, then angle PQT PQT and angle PVR, which we didn't otherwise have any information about, but we do know that they're corresponding on the two triangles. So what can we do? We can say that because corresponding parts of congruent triangles are congruent. And that's all we need to do.